Hello CS6460 Summer 2018. This is the final presentation of the final project of Team BUMS. Members of Team BUMS are Prakhar Srivastava, myself Karan Kendri, and Avril Euthis. And we have developed a web application called Brain Understanding Management System, or just BUMS because that's quite a mouthful. And the goal of our application is to provide users with a useful representation of a learner's knowledge space to help identify and remediate gaps. Before we get into details, I want to take you on a quick demo of our application, which can be accessed at this link. And this initial demo will provide some context for what we're going to talk about, and then we'll come back and explore the full functionality. So this is the page you'll land on when you first visit the page and have never visited before. There's a little blurb here explaining the app, and you can do a sample quiz. Now, the knowledge domain that we are working on for this application is the Pythagorean theorem. We hope to expand the knowledge for future work, but for right now, we wanted to keep it narrow and focused. So this sample has a subset of questions from the full app. I'm just going to answer them semi-randomly. It's kind of hard to answer randomly since I know all the answers after having taken it like hundreds of times, but I'll do my best. So that's the quick test. You press submit, and you are taken to a page where you have a knowledge graph on the left. This knowledge graph represents how well you understand the concepts you were tested on. Each node that I'm moving around here represents a concept, and as you can see, the concepts are linked in certain ways based on these lines that link them. This bar here shows you a key of how well you understand the concept. Green means you have a solid understanding, orange is a fair understanding, and red is a weak understanding, and the whole gradient of colors show up based on your results. We also have some learning resources here to help you understand the Pythagorean theorem. So let's get into how the application works. The knowledge graph is made up of nodes and how the nodes relate to each other. Each node represents a concept, and each concept can be applied to certain problems, some of which you saw in that sample test, and each concept can also be demonstrated by certain resources. Now we need to expand upon the resources for future work, as right now it's pretty much just a static library of resources to help with the Pythagorean theorem in general, but eventually the resources will be more customized to the current state of the user's knowledge graph. So each node or concept maps to a frame which contains useful information for the application about that concept and its context in the knowledge graph. So it can contain information about the problems that apply to the concept, the resources that can help you learn about it, and the current user's level of mastery, plus other metadata that we need for the application. This slide is just meant to show how we've structured our knowledge, and we're using the idea of the epistemological order of concepts, which we saw in a lot of research, which is basically the idea of the proper order for learning. So for example, to know the Pythagorean theorem, you need to know what a hypotenuse is and how to identify it. To know what a hypotenuse is, you have to know what a right angle triangle is and what a triangle is. And these blue rectangles sort of represent the backbone of our knowledge graph, but as you can see, many concepts will interrelate to each other, and as we expand the knowledge space, this structure will expand and get more complicated, which we will use for future work. So this is just a representation of how everything sort of works together. For example, a certain concept can relate to multiple problems, or can rather apply to multiple problems, and many resources can teach you about a concept. So since that's just a whole mess of arrows, let's look at it in this context. If we just isolate the hypotenuse can be tested through drill problem 4, drill problem 1, and graphical problem 5. Answering these questions can give the application information about how well the user understands the hypotenuse. The hypotenuse can also be learned about from lecture 6 and example 8. And the hypotenuse can map to an example of a frame over here, which contains information about its epistemological place. It's above the Pythagorean theorem, below right angle triangle, the resources that you can learn about it from, and the problems that it applies to, plus the user's level of mastery. So, and finally, this is a high-level application workflow. So we've already seen a knowledge graph that you get generated from when you take a test. And we've already talked about how each node maps to a frame. Now, when you want to test your understanding, you don't want to retake the entire test every time. You want a test that's custom built for you based on the current state of your knowledge. So that's what this represents over here. We take the relevant information from the frames, such as the problems related to the concepts you're weak on and your level of mastery, and we build a customized test for you. We then take the results of the test, put it through some algorithms, and we then update the frames that the test initially came from, which in turn updates the knowledge graph to show you your current state of understanding. Now let's go and look at more of the functionality of the application. So I just registered an account before starting this video, and I'm going to log into it as if it was the first time I used it. So, secret password. So this is the first time I'm here. I'm going to take my first test. And for this test, I'm going to intentionally get everything that I need to know prior to the Pythagorean theorem correct and everything else wrong or answer randomly. And I've done this test a bunch of times, so I can breeze through it pretty quickly. And when you guys play around with this, you can take your time with it, and I encourage you to try different combinations of answers to see what kind of knowledge graph you'll get. And so now I'm going to start answering kind of randomly just to get some wrong, or intentionally try to get them wrong, rather. And these are some free text answers. I'm just going to answer 0 for everything. Submit. Here we have my knowledge graph. So I clearly know nothing about isosceles triangles, and I clearly know nothing about Euclidean distance. I have a fair understanding of right-angled triangles and the hypotenuse, but sort of less of an understanding of the Pythagorean theorem. It's a little subtle, but as you can see, this is closer to red than the hypotenuse. And so this kind of gives me an idea of my current state of understanding, and we have some resources here to learn from that we need to work on. And so now when I retake the test, originally there were 20 questions, now I have 11. These 11 test me on the concepts that I was weak on. So let's try to get all of the Euclidean distance questions correct. So starting here, this is related to Euclidean distance. So is this not really, but I'll just get it right anyway. This is also Euclidean distance. So is this. So is this. And these are related to isosceles triangles, which I will still get wrong. So, as you can see, I have mastered Euclidean distance. I got all of those questions correct, and I sort of improved my understanding of some of the other concepts. I got closer to red, but I still don't know anything about isosceles triangles. Now I'm going to retake the test and get the isosceles triangles questions right. So the reason these relate to Pythagorean theorem is you can divide an isosceles triangle into 2 triangles and 2 right-angled triangles, which can help you solve for it. And so now I've got all of these right, and I have fully mastered all of the concepts in my knowledge space. So that is a tour of our application. Thanks for watching, and I hope you guys had a great semester.